SwayamPrabha. Digital India. Educated India.
Design for IT manufacturing. There are certain points regarding the additive manufacturing process which we need to discuss. The first thing is about limitations. The traditional manufacturing process have a lot of limitations, and this is applicable for both traditional and non-traditional. Traditional means the machining process which we generally use often for manufacturing, like lathe machine, milling machine, other things. Non-traditional processes which are related to non-traditional machining processes like EBM, wire cutting, EBM, wire cutting machines which are used like chemical machining, wire cutting EDM, and various others. Now, when the technology is advancing, there are requirements from a design point of view that we should make complicated shapes, and traditional machining processes may not be able to give us all the possibilities of making these shapes in an economic way. So the need for making complex shapes which are economic, it is right now is the time, and there are a lot of designers who are moving towards designing products which are complex in design, is more ergonomic. So it is not that these manufacturing processes, both traditional and non-traditional, cannot make this kind of products. They can. However, these are all a very expensive process if you wanted to go for making it. So that way we need some other technologies, and additive manufacturing is one of the way we can achieve this complexity. Making the products, complex products, is much more cheaper. This traditional machining process, which means that which includes CNC machining. CNC machining, it is much more accurate, but it takes a lot of time. So it takes actually lot more time to make the product, because we need to understand the product, make CNC code and put it in the CNC machine, and even then, depending upon the complexity of the product, we need 5-axis, 7-axis CNC machines, and this machining process is going to take a lot of time. So time for machining nowadays is something which is very less, because companies want to manufacture product faster. So how to enable them to manufacture product faster, especially for complex geometries, because smaller geometries which can be done mass produced, like using injection molding, that is much more efficient if we can use mass manufacturing processes like injection molding. However, some of the components which are complicated shape and also batch produced, less number of components need to be manufactured, then additive manufacturing process is a better solution for this. When we have prototypes, especially when we are designing, prototype is very important. So we need to have prototypes, something like making the prototypes and filling it, testing it. This cannot be done directly using AR and VR, like augmented reality and virtual reality. Partially can be done, but not completely. That's the reason we need something which can be done, or which can be felt physically, which can be analyzed physically, which can be maybe we can do some analysis of the strength and other material properties, and also we can see how the product is on all physically. That's the reason we need some kind of technology which can make and help us to make the product physically, and additive manufacturing process is one such technology which can help us in making the product very fast. New design styles are coming, we need support for that. And when we have the additive manufacturing process, we need to change the way we are thinking previously we are thinking that when you're designing, we need to think about manufacturing, right? But in additive manufacturing process, when you are thinking, there are a lot of limitations which are there in traditional manufacturing process are not there. So we need to change the way we are thinking. So design for manufacturability need a clear thought, you need to change, a shift and paradigm shift is required from the way we are thinking, that is designing, when we are designing a product which is traditionally being manufactured in traditional manufacturing process. Now we are going for design within additive manufacturing process. So the unique capabilities of additive manufacturing is to enable new opportunities for customization, which is very significantly improve the product performance and multifunctional and lower the overall cost. There are certain unique capabilities of additive manufacturing process. One is shape complexity. Shape complexity means it is possible to make a really complicated shape using additive manufacturing process. Hierarchical complexity. Now, previously we used to have same kind of material in general, but now in the hierarchical complexity there are multi-scale structures which can be designed from the microstructure through the geometric mesostructure, and then scale up is also possible. Layered manufacturing is possible using multiple materials using it. So all these possibilities are there when we are making using additive manufacturing process. Next is material complexity. So traditionally, if you want to have multiple layered materials in a product is very difficult, but in manufacturing process, with additive manufacturing process, this is quite easy, because the same machine can be used to manufacture products using multiple different kinds of material at different layers of manufacturing process. Functional complexity. Previously, we used to have a product which is having just a component when we are manufacturing, and then of course we are assembling multiple components and making a system work. But now we have complete freedom. A lot of freedom is there, where functional assemblies and mechanisms can be made, compliant mechanisms can be made, mechanisms which is difficult to manufacture using normal traditional manufacturing process, because very small and very thick materials component size can be manufactured in the same machine. So if you want to go for micro manufacturing process, traditionally the machine is different. For normal manufacturing process, machine is different, even though both are CNC. But in CNC, in AM process, that is additive manufacturing process, all these possibilities are there, where the same machine can be used for making very small structure to large structure. So in the same structure, we can have multiple of them. Now, in contrast to DFAM, that is design for manufacturing, with the design for manufacturing, the normal design for manufacturing, we are actually making a products, but in design for additive manufacturing, we are maximizing the product performance using synthesis of the shapes, sizes, hierarchical structure, and then subject to capabilities of AM manufacturing process. This is possible because we are making things which are easy for the designers to think and manufacture, because they know now that a lot of limitations are gone. They can make machines, they can make products which are much more complex. There are several guidelines which can be used. One is that complex geometry can be made. Now, complex geometry can be made by using normal manufacturing process also. But in additive manufacturing process, the time required to make complex geometries and simple geometry is almost similar, because it depends upon the amount of material, and then the shape, overall type of the material, and the build volume. So the difference will be very less if you want to make a simple product or complex products of the same shape. Whereas in the normal manufacturing process, not like that. It is very different. And additive manufacturing process enables user of customized geometry for each and every component which you make. Each and every component can be customized, because 3D model may be different. So 5 different components we are making. Normal traditional manufacturing process, it is difficult because you need to change the coding efficiency, or in normal manufacturing process you need to know and change the process. But in additive manufacturing, we just change the CAD model, make the Excel file which is different from different product, and then print it. So it is possible often to consolidate part. We'll see that how multiple parts can be consolidated into one, which means that when one component may have been made using multiple parts in using traditional manufacturing process, because that was easier to make, because casting was easier. So we cast different components, machine some portion of it, assemble it, and then you make. But in IT manufacturing process, maybe all these components not require just one simple contoured shape component may be enough. So that can be done using additive manufacturing process. It also gives an opportunity to the designer that you can ignore all the constraints of the conventional manufacturing process. And in additive manufacturing process, the number of constraints which are very less. So complex geometries we can make. So layered by layered complex geometry we can make. But we should also understand that Z direction, the strength of the material in the additive manufacturing process is different in different directions, depending upon the kind of machining process which we are following. That we should understand. So complex geometry process, when we are making, you can make it in additive manufacturing process. Customized geometry, that I already told, that we can change the design in very fast. So in integrated assemblies we can make, where additive manufacturing process is actually enabling integration of features, whereas in traditional manufacturing process, if you want to do it, you do it in different components and assemble it. So it is going to reduce the cost a lot. Of course, mass manufacturing using additive manufacturing is something which is challenging yet. Still it is challenging. Now traditionally this design for manufacturing has a lot of constraints. Like, rectangle slots, if you want to make, you have to think, how can I make? So when a designer is giving a rectangular slot in the design, he may try to avoid it. But in additive manufacturing, those things are not there. So there are much fewer constraints. Then the design culture, where the space is limited, that is also the people have been thinking in different direction now. So the design constraints which are there, especially due to manufacturing, all these things are gone. Now the designers are having a lot of freedom to think that we can make complicated shape parts without affecting the cost of the product. So This is going to change the way designers are thinking. So design thinking, when you are using design thinking in additive manufacturing process, with additive manufacturing, is going to change the way people are thinking products and how to design it. Because the manufacturing constraints are all reduced now. Many of them are reduced. So another thing is shape complexity we can have. So all these things are possible using additive manufacturing process. Hierarchical complexity we can have, that is in terms of hierarchy. We can make materials hierarchy. Functional complexity, material complexity, all these things were possible in additive manufacturing process now. So now designers will have a possibility of exploring design freedom. Multiple parts are made together. It is much more simplified. So we are seeing a world now where, especially in the area of design and manufacturing, things are much more simpler and customizable, economic, etc. So parts consolidation and redesign. So especially this is important when the low volume production is there. If you want to have more parts, it is going to be expensive. So parts consolidation is something which is important to have. Hierarchical structures we can have. Industrial design application. The industrial design things are very different, where we need products which are looking beautiful, attractive, which are aesthetics, which means that they're attractive, and also ergonomics. It will be suitable for people who are going to use it. And this is possible when we have additive manufacturing with us. Okay, now we will have two examples in which we would learn how part consolidation is going to be an important step in this additive manufacturing. So let me draw a example of it. So let us imagine there is one part like this, which is there. This is the valve 1. The down portion of the part. This is the other part which is there, and it is having some kind of way to screw the part together. Inside there is another component which is going to be like this. Which is the separator. Duct this is. So this is top portion of the duct. And this is bottom, and this is the separator. Now this is having lots of components. Immediately this is now we are going to make in additive manufacturing, so we don't need to have these components. So here you see a lot of screws will be going up. Okay. So all these required things are there. So now instead of doing all this, so we can make a single component which is going to be consolidated one. So let me draw that one first. So in this one we will see another example, and take for example that we are going to have this kind of component. Let's say this is water housing, pipes, and these are junctions. These are screwed with respect to each other. We have third component. This is component 1. Component 2. This component 3. Now instead of having so many components and having screws to join it, we can just use a single one, and that is going to be like this, something like this, because we are using 3D printing, so we don't have to really worry about this. So we don't need any junctions, and directly we'll get the part like this. So this is component. So it is made with additive manufacturing. So you get the single component like this. Now we'll have another example. Imagine there is one component and it is having a hole here. So down of it, this is made using there is one other one similar to this. And there is another component is coming like this, and this will be welded in this place. So now, instead of having this one, what we can have, we can, using additive manufacturing, we can have, instead of all this one, we can have single one. So you can see from here to here we have one component 1, component 2, component 3 plus welded. This is and then we have also nuts and bolts, and all these things in this one we have single component. Yeah, so I think you have now learned how easy is to simplify the design now using additive manufacturing. Now 7 principles of additive manufacturing process. First is think additively. Previously we used to think subtractively, which means that whenever a component is there, we used to think that how can I make this component. So let's say I have this component. Previously I should think that okay, I have this rectangular bar, and then I'm going to use a method to cut, and then whatever is pending, whatever is remaining, it is a component, which means that I need to use a wire cutting medium maybe, or a very small very accurate milling machine, micro milling. Now in additive manufacturing all these things are not required. We have to just use the machine and print it, because it is like addition to each other. So the first thing is think additively, change the way we are thinking. Design for orientation is because in additive manufacturing process, the orientation, if you change, it is going to affect the quality of the product, it is going to affect the time of the manufacturing process, and also is going to affect the cost of the manufacturing, because if you change the orientation, the support material which are required during the manufacturing process, it will be different. So for some configuration you may not require support material, for some other configuration you may require, and then where the strength is required, which side the strength, which portion, which direction the strength is required, on that basis you have to orient the process. Counter design, where it means that where we can make counter design, that certain portion can be printed with just 1 or 2 extension lines, and with the extension lines you can really lightweight but strong parts can be made. The segment and bonded parts, this is another way we can have that. If you have bigger product, how we can manufacture, so make small products, small, and then assemble it, so that with bonded. So that is possible in additive manufacturing process. In other manufacturing process, difficult. You can add hardware. One can add hardware while manufacturing is going on. One can add hardware. So it will become a more directly a complex product directly can be made. Minimize complexities means in this we can make the products much more simpler with less material. and critical surface treatment, that can also be done. So when we are talking about additive manufacturing process, we should also understand is not just about some limitations are there. The limitations with respect to CAD model also, CAD systems. So what are the limitations of CAD systems? CAD system which is there, ProE, Ideas, Unigraphics, UX, NX, SolidWorks, CATIA, Rhino. There are so many softwares which are available. However, many of the software are not really designed to take care of the additive manufacturing process, because in a CAD software, many of you would have used it, that if you want to make really complicated shape, this is sometimes difficult using CAD model. It will take a lot of time. Second thing is, the material which are there in the CAD system, if you want to make a CAD model with multiple materials or composite materials, is difficult. Nowadays, recently people, CAD softwares are adding this facility, but if you think that there are variation in the material across the product surface, if you want to make that kind of material, if you want to model that kind of material in the CAD system, that is something which is still difficult. And if the complexity is high, analysis is going to take a lot of time. That's another problem. And the third challenge is representing physically based property distribution. And so if you have a property distribution of a product across component, from one place to another is varying, and different components having different material is made. Okay, then how do you model it? That is something difficult. There are a lot of challenges there involved in this one. Thank you.